Lesson 4, the shape of distributions. So in class we did a worksheet where we learned that there were 4 different names we could use to describe the shape of data, how data is distributed. Skewed, uniform, bell-shaped, and bimodal. And then we also had a 5th name, symmetrical. And some of these 4 could also be symmetrical. So on this worksheet, now this is our note sheet rather, we're going to identify these 4 types. So what your task is to look at these 4 examples of data sets. So 2 on this page and then 2 on the other page, and decide which one is skewed, which is uniform, which is bell-shaped, and which is bimodal. So pause the video and try that on your own. Okay, so this one here, if we look at the dot plot, it's shaped like a bell. That is bell-shaped. In this one here, the data is more on one side than the other. And so this would be skewed. In this one here, all the data is evenly spread out. Every in this case, data point has the same number of values. So this is uniform. And then this last one, the data has kind of 2 separate groups where there's the majority. So we call that bimodal. Bi meaning 2, and a mode in a data set is where you have a lot of data. So here's one mode, and here's the other mode, bimodal. All right, then you're going to go back, and for each one of these, you're going to look at the histogram and the box plot, and then fill out this information down here. So remember, this is the 5-number summary, and sometimes we calculate and fill in a 5-number summary box first, and then create the box plot from that. In this case, we're given the box plot, so we can actually use the box plot to fill in the 5-number summary box. So remember, in a box plot, the vertical line, so here's a vertical line, here's one. All of the vertical lines are the 5 numbers, the 5 important numbers. So let's remember what they are. The one at the lowest end is the minimum. So in this case, we have a vertical line here at 7. So we don't know what the question is. It could be something like, how many chocolate chips are in a cookie or something. So in this case, 7 is the minimum. This is going to be a cookie with a lot of chocolate chips. The maximum, 17. These must be very big cookies. So the highest vertical line represents the maximum. The median is drawn in the as the middle line, 12. And then Q1 is the first quartile. So that is the median of the bottom half. And that is this vertical line. Q3 is the median of the upper half. And is this vertical line. So the third quartile is 13. So now we're going to calculate the mean. So in calculating the mean, we're going to have to look up here at our dot plot, because our dot, that's probably the easiest one to calculate the mean, because it shows us each value very clearly. And remember that to calculate the mean, you have to, it's the sum of all the values divided by the number of values for data points, right? So when we add up this sum here, can start. I'm going to leave myself a lot of room because there's a lot to add up. There's 1 7, there's 1 8, there's 2 9s. Here's how I'm going to write this. I'm going to write 9 and then parentheses, meaning times 2. And then there's 3 10s, 10 times 3. There's 5 11s, 11 times 5. There's, hold on, I wrote this down earlier. There's 8 12s. There's 5 13s. Whoops. 13 times 5. 14 times 3. See how there's 3 values at 14. 15 times 2, and then 116 and 117. This is going to be tedious to put into the calculator, but we will learn soon how to use a spreadsheet to do this calculation for us, which is very helpful. And then we'd have to count the number of dots to figure out how many there are. I've done that for you. It's 32. There's 32 of them. So on a calculator, we can add all of these up, and we get, sorry, we're kind of bleeding into the next one here, we get 384 on the top divided by 32 on the bottom, and that equals 12. Look at that. In this case, the median and the mean are the same, and that is true with bell-shaped data. The median and the median, if it's a perfectly bell-shaped data, perfectly symmetrical, will be the same. Okay, so for this next one, you will do this one yourself. You're going to have to identify the minimum, the mean, maximum, and then Q1, Q3, and then find the mean. And so you'll do that for each one of these. And once you find the mean for this one, you will see that the mean and the median are not equal in this case. They're usually not equal when you have skewed data. In a uniform distribution, you'll do the same thing. You'll fill out this box, you'll calculate the mean, and you will see, in this case, the median here, 12.5, and when you calculate the mean, show your work, but when you calculate it, you will see that it also equals 12.5. So in a uniform distribution, the mean and the median are equal. Okay, last one here. You're going to fill this box out. You're going to calculate the mean. And here's a little note here. Bimodal distributions are not always symmetric. They can be. For example, the peaks may not be equally spaced from the middle of the distribution, or other data values may disrupt the symmetry. In this case, if we look at the dot plot, we can see if it's symmetrical. The histogram really makes it look symmetrical. In the histogram itself, that image is symmetrical. But if we look closely at the dot plot, which shows us each individual data point, it's not exactly symmetrical, because we have this one little value here at 19. If we were able to add a value at 6, that would be symmetrical, but we don't have a value at 6, so this particular example is not symmetrical. So bimodal can be symmetrical or not symmetrical. All right, so fill the rest of that